solid fuel rockets and liquid rockets. These are properly they are properly known as rocket engines, and they can be solid or they can be liquid. Solid is one of the popular example is the Diwali rocket, where the combustion products are in solid phase, whereas the rockets used in PSLV second stage are liquid rocket engines, which uses fuel in form of liquids. So next, coming on to this air breathing type of engines, they can either use the surrounding air to propel. Then they can use same atmospheric oxygen to run some combustion process, and that exhaust gases will be eliminated in form of thrust. Then there are other engines that partly uses this surrounding air for the combustion process, and the other one is the expansion through the turbine. So yeah, we'll be dealing with these individual components in the later slides. Yeah, so yeah, let us move to the air breathing engine versus non-air breathing engine type. So here you can see this Airbus. These are the commercial flights, which uses this turbo fan engine. These engine rely on atmospheric air for the combustion process, and this is eliminated in form of this hot gas, which helps in the propulsion process. Whereas the non-air breathing type, this is Raptor engine with Raptor RP1, which is SpaceX, which currently SpaceX is using. So these engines, they take the thermal energy from the oxygen that is coming from a tank and some kind of fuel, which are also stored in form of liquid. So these engine does not rely on atmospheric oxygen for the combustion process. Yeah. So coming on to this classification of the rocket engine, these are the non-air breathing type of engines. They can further be classified on the state in which the propellants are used. So this can be liquid rockets where the oxygen and liquid fuel are stored. Then they are passed on to the combustion chamber. This is a combustion chamber. These gases react and then they expand through some special type of nozzle, which are known as convergent, divergent nozzle. So we will be studying all these things in the later part of the course. Yeah. So next is this. The fuel can be also in form of, these are the liquid engines. Liquid rocket engine. So the propellant can also be in form of solids, which is similar to this rocket, the Diwali rockets, where the solid gunpowder or any other propellants are stored in form of solid. They are casted into a tube where the combustion happens and they expand through the CD nozzle and they generate the thrust. Yeah. So this is one of the solid rocket motor which is used by NASA, and this is how they are tested. So another part is we can use a combination of solid as well as liquid. These are known as hybrid rocket engines. These are hybrid. rocket engines. Yeah. So they have fuel in form of solid and they pass liquid, and this help in surface reactions, and this surface reacts with liquid oxygen and forms gases, and then they expand through nozzle. So these type of engines are known as hybrid rocket engines. So coming on to the classification of air breathing engines. So air breathing engines can be further classified on the basis, they can be classified as turboshaft engine, turbojet engine, turboshaft engine, turbojet engine, turboprop engine, and turbofan engine. So turboshaft takes the air, and they provide the mechanical energy to a shaft which runs this blade, and this helps in generation of thrust. Yeah. So whereas there is very similar to there is a engine very similar to this turboshaft engine, which are known as turboprop engine, where the energy comes from a propeller, and this uses air through this port. Another category is a turbojet engine, where we take the air, and we will see how the different engines look like. And these are and there is one more category that is known as turbofan engine. So this turbofan engine are mostly used in commercial air flights. These are used in fighter jets. These are used in helicopters, and these are used. They are used in small airplanes, probably business class type. And yeah, so one very important point about this turbo prop engine is that they cruise at a very low altitude, whereas turbojet, turbofan, and turboshaft also, they cruise at a low altitudes, whereas this turbojet and turbofan, they can cruise at a very high altitude. Yeah. So yeah, this is the difference between the image here shows the difference between the air breathing engines for three type of aircrafts. One is the turbojet, turbofan, and turboprop. So in one of the remarkable difference that is there in a turbojet and turbofan is the presence of a fan. These are the compressor stages. Okay, this is fan, this is compressor stage. This is low pressure compressor. This is a high pressure compressor. Then followed by this combustion chamber. Where the combustion occurs at a constant pressure. And this series is high pressure turbine, pressure compressor, pressure turbine, and this is low pressure turbine. Yeah. So the turbojet engine is very similar to turbofan. Only the difference is we don't have a fan to generate extra thrust. So this turbojet engines are used. They have low efficiencies as compared to. Okay, efficiency does not make much sense in air breathing engines. So there is one more term. This is known as TSFC. That is known as thrust specific fuel consumption. consumption. So yeah, so for this turbofan, the TSFC, the amount of fuel that is required to generate 1 Newton of thrust is known as TSFC. So one, it is just how much amount of thrust and what is the amount of what is the weight of the flow mass flow rate that is being used. So this is known as thrust specific fuel consumption. For this turbojet, the TSFC is low as compared to turbofan. The highest TSFC is for turboprop engines. This is yeah. So these things will be taught in the later part of the courses. Yeah. Coming on to this supersonic, there is another type of engine which are known as which are used for cruising at a supersonic speed. These are known as ramjet engine and scramjet engine. So there is a when we cruise at a higher Mach number. So what happens? There is a phenomena that is known as shock wave generation. So at higher speed, these turbofans will create individual shocks, and these shocks are the reason for creation of inefficiency. They make the system inefficient because there is something known as stagnation pressure loss. Yeah. So these things creates inefficiency. To counter this, we have something known as ramjet engine and a scramjet engine, where we don't have compressor to increase the pressure. So we use a shock wave to increase the pressure across the inlet. This is the inlet. This is the combustion chamber. Inlet, combustion chamber, and this is the nozzle. This is the nozzle. So one of the difference between ramjet and a scramjet engine is the combustion. In case of ramjet engine, occurs at a subsonic flow, which means Mach number at the combustion chamber is less than 1, whereas in scramjet it is greater than 1. That's why this scramjet means S stands for supersonic, C stands for combustion, and then just a ramjet engine. So these type of engines are useful to cruise at a high altitude. So first image that you saw is shown here is a scramjet engine, which was tested by NASA in 2001. This is X43. Yeah, and this is Concorde, first commercial air flight to cruise at Mach number greater than 1. This is known as Concorde, and this traveled at Mach number 2. Now this is not operational. Yeah. So yeah. So there is another type of engines which are now currently being used, and they are in current. There is a heavy research that is going on in this field. That is known as hybrid air-bearing type of engines. In this type of engines, they can transition from one type of engine to another type. So for say they can switch from turbofan to to a ramjet engines. So yeah, so these are known as hybrid type of engines. So one of the best example is this is Lockheed Martin engine. So this is a hybrid type of the engine that is being used is a hybrid type of engine where it can transition from a turbojet to ramjet engine, ramjet transition. this can be switched in these type of engines. Yeah. So yeah, MMH. So this stands for mixed oxide of uh, oxides of nitrogen, and this is mono methyl hydrazine. So these are known as hypergolic propellants. They does not require any type of igniters. So when we just have to when they come in contact, they generate enough thermal energy to uh, to carry on the combustion process. Whereas the other type of non-hypergolic type propellants, such as liquid oxygen (LOX) and liquid methane, they require a separate ignition source. Mach number. This compressor will work, and this yeah, 1 minute. Yeah, so this thing, the combustion will happen in this part, and at supersonic speed, what happens? This cone, this cone acts as a uh, acts as a this shock wave guide. So at higher Mach number, what happens? This compressor stage is closed, and yeah, and it bypasses and acts as a ramjet engine. Basically means the combustion products that is there, they are transferring their chemical energy into thermal energy. This is energy transformation. Whereas energy transfer is the energy transformation is from one form of energy to another form. So consider this. There's a work done. 1 minute. So 1 minute. I'll remove this part.